All right, we're going to start with 3.3, quadratic functions. That's where we start in chapter 3, is at 3.3. So a quadratic equation, when graphed, is called a parabola, is a function of the form y equals ax squared plus bx plus c. Okay, a, b, and c are real numbers, and a does not equal 0. If the a value, this first a value is positive, so this means positive, the parabola opens up. And if it is negative, the parabola opens down. Every parabola has a vertex and an axis of symmetry, which I sometimes call AOS. All right, and so I'm just going to write a random parabola over here. I'm not going to make it the parent one, just something like that. So this is obviously one that opens up, so this a value, this lead-off coefficient, would be positive for this example. The vertex is for one that opens up is the minimum right here. And the axis of symmetry is just going to split the parabola in half. You'll see symmetry on either side of this AOS, which is your axis of symmetry. It's a vertical line, so it will always be x equals some value, and that value is actually going to be the coordinate, the x coordinate of the vertex. So we'll go ahead and get the vertex labeled with the correct letters, and those would be h and k. Okay, the domain of a quadratic function is always, so this is infinitely left, and this is infinitely right. So this is negative infinity to infinity. And again, think back, we don't have a denominator, we don't have an even root, so this is going to be your go-to in that situation unless it's piecewise. So we are going to solve quadratics in 4 methods. The first method here is factor and apply the zero product property. All right, ZPP. And the ZPP basically just says, I'll just write it really little up here, if a times b equals 0, then a has to equal 0 or b has to equal 0. There's no way to get 0 out of a multiplication unless one of those equals 0. There's not like a 6 product property. If you have a times b equaling 6, that doesn't mean a has to equal 6 or b has to equal 6. They could be, 2 and 3. But when 0 is over here, one of those has to be 0. So this is why we're always saying set it to 0. Set it to 0, and so we're going to factor it. So 2x and x, that splits nicely. And then we just have to be strategic with the 3. I have different signs because this is negative and I need to build to 5. So I'm going to put a 3 on the outside with 2, so that's 6x. I'm going to make that a positive 6x. And then a 1 here, so that when I have positive 6x minus 1x, that builds that positive 5x. So if you did a mental check, you'd get 2x squared plus 6x minus 1x, which is 5x, and then minus 3. Okay, and so then you use your zero product property and set both of those equal to 0, and just solve each one of those little linear equations. So x is equal to 1/2 here, and x is equal to negative 3. So, this is asking us, where does the function cross not only are these solutions, but as a parabola, where do we cross the x-axis? These are x-intercepts. These are zeros, all of that language that we use, x-intercepts, zeros. So we'll put 1/2 right there, and negative 3. 0 here, and then 1/2, 0 here. Just adding on to this, if you were to check graphically, you would see a confirmation of the zeros that we just found. But adding on to this, you could also very easily see that this is going to, if you did the y-intercept, if you zeroed out x, you would get negative 3 here. So we can add that to our graph just because it's easy to find. And then we're just going to we're not going to find the vertex yet, that comes later, but we could just do like a rough sketch here. We're going to talk about how to find this HK soon. Little foreshadowing there of what we're going to do in the future to find out HK. All right, so So the next one is the go-to. If you can't factor, most people go immediately to our quadratic formula. So this works in all situations. You just have to memorize the formula, which I'm sure you already have. Quadratic formula. And as always, this also finds the x-intercepts. Anytime you're solving, you're finding the zeros or the x-intercepts, where y is zeroed out. You're on the x-axis. And so this one is the same problem as before. So, it would factor, so I would not recommend the quadratic formula. But let's say you don't see the factoring and you just want to go straight to the quadratic formula. So it's solving for the x-intercepts. So x equals, and the formula is negative b plus or minus square root of b squared minus 4ac all over 2a. So however you want to, however you remember that. Some teachers teach a little thing about a party and all over at 2 a.m. and some teachers do the Rolling in the Deep song, or most people can just memorize it. We can prove that where this comes from. This isn't just made up. There is a proof of this that maybe we can look at in class one day if we have some extra time. Okay, so we're not going to factor it. We're going to do the quadratic formula here and see that you get the same answers. So x equals negative b. So the opposite of this b value right here is the x term. The opposite of the b value, which is negative 5, plus or minus. That gets us our potential two solutions here. B squared, which is 25, minus 4ac, which is negative 3. All over, that all over is important, 2 times a. And our a here is also 2. This 2 is built in. This is the 2 from our a. All right, so I'm probably going to run out of room, but this is negative 5 plus or minus 25 minus that's 24. 8 times, that's negative and negative, which is positive, and so that's going to be positive, and that's 8 times 3, which is 24, and so we get 49 all over 4, and so x equals negative 5 plus or minus root 49. Now notice that is a perfect square. 49 is 7 times 7. That's just my little thought bubble. 49 is 7 times 7. So anytime you get a perfect square under here, that's a hint to you that this would have factored. If you get something, those perfect squares, the 1, 4, 9, 16, 25, so on and so forth, that means, hey, it would have factored. But it's okay. You can still solve it out. So I'm going to move over here if that's okay. So x equals negative 5 plus 7 over 2, and then case 2 there, x equals negative 5 minus 7 over 2. So x equals, this is going to be our 2 over 2. All right, this is our 2 over 2, which I screwed up. Sorry, this is our 2 over 4. Why did I transfer a 2 over here? This is our 2 over 4, which is our 1/2. So this is a learning moment. Let me just finish this out. So this is negative 12 over 4. This is a learning moment. Notice I knew I was doing the same problem, and I knew, I should get the same answers as above. And so when I wasn't getting those same answers, that's an opportunity for me to, not just forge ahead and say, oh, that's weird. This is an opportunity for me to say, hey, I made an error somewhere. And sure enough, I just transferred this 4 over incorrectly, caught it, and then was able to rebound and see that we indeed get x equals 2, 1/2, and negative 3, which is the same as above. All right. Okay, so that is the second method. The third method is completing the square. And what am I going to write here? Also find the x-intercepts. They all do that. Completing the square is not great for this. I would definitely use the quadratic formula, but we use the completing of the square quite often when we deal with getting the vertex or when you deal with conic sections. So it's a great strategy, a great process to know how to use. Okay, so this is kind of a long list of things we have to do here. If not there already, move the constant to the right. So we're not setting it to 0. So move that constant, which is what, that C value here. That C value. Move that to the other side. If there's a coefficient in front of the square term, you must factor every term by that number. Yes, that means you might have to multiply and add fractions when you factor it out if it's not a nice, easy division. Create an empty space on each side of the equation, leaving room to complete the square. All right, so take half. This is the key. I mean, you've got to get it all set up, but this is kind of the language that goes through your mind. Take half of the coefficient of the middle term and square it. All right, write that number in the empty space, adding it to both sides of the equation. Factor the left side of the equation and add the numbers together on the right. All right, so what you've done when you complete the squares, you've created a perfect square trinomial. So when we factor the left, you're actually going to get a binomial square. So we're going to note that on 5. You've created this perfect polynomial, trinomial that will factor as a binomial squared. All right, and then we're going to use the square root theorem, which is actually method 4. We're going to take the square root of both sides. Don't forget the plus or minus. That plus or minus is the same plus or minus that's here, and that's built into the square root theorem. Simplify radicals if needed. So if you had like root 32, you would want to make sure you wrote it as 4 root 2. So we'll talk about all that as we go through these. And finish the problem by adding or subtracting the last number on the left side to the other side. This will create an expression that looks like an answer you would find from using the quadratic formula. Not the one that's above, because it would factor, so these are easy, but one that, you know, when you get a quadratic formula that says -4 plus or minus root 33 all over, you know, 6, something like that. You're gonna get something that looks like that will look familiar to you. And again, because they're all procedures for solving the same type problem. All right, so here we go. We're going to solve by completing the square. This one actually factors, so that would be preferable. Factoring this one would be best, but we're going to complete the square. So I wouldn't memorize those steps that are above. I would just practice problems, and then you'll just kind of know how to do it from, you know, muscle memory, if you will, or brain memory. So I've moved the constant to the other side. So that's step 1. If there is a coefficient in front, you must factor it out. There's not. Yay, we like that. Create an empty space, leaving room to complete the square. Did that. So this is all steps 1, 2, and 3. All right, so I'm going to complete the square. This is the important piece. I want to take half of the middle term, which is -4, and square it. So that's 16. I took half of -8, which is -4, and squared it. 16, 16. Okay? So factor the left into that perfect square trinomial. And so that's x minus 4, x minus 4. So I write it as a binomial squared, x minus 4 quantity squared. And over here I get just 1, which is nice. And now we're at step 6. Take the square root of both sides. And this is using the square root theorem, because you're going to square root this square. Well, I've got those a little bit. It doesn't really matter. They're the same part of PEMDAS, but I'll just write it like that. I'm going to take the square root of both sides. Don't forget the plus or minus. And that square root's just going to negate the square, so I'm going to get x minus 4 equals plus or minus 1, and then just split the 1 and the -1. So take that 1 and -1 and split it, and then we're adding 4. So it's going to be 1 plus 4 and -1 plus 4. And so these answers are 5 and 3. Okay, that's where it will cross the x-axis. Those are x-intercepts. Those are zeros. Those are solutions. And, I mean, if you were just to factor this, it's pretty easy to see that that is what you would get, 5 and 3. You know, obviously factored if it'll factor. Okay, so the second one is going to be a little bit more difficult because we've got that coefficient we may end up with a fraction here. So move the constant to the right, factor out the 2. So when I factor out the 2, when you factor, you're dividing. So this is x squared, so I just took 2 divided by 2, factor that out, and then when you factor it out of the 5, you're going to get 5 over 2x here. Okay, so you could go ahead and move the 2 out of the way. That's probably what I would do. I think that's going to be easier in terms of leaving it, because when you leave it, you have to complete the square, but ultimately you have to take this piece and multiply it by the 2, and that seems to lose students. So I would just clear it out and bring it over to this side right away. So x squared plus 5 over 2x is going to equal to 3/2. All right? So let's do that important piece where we complete the square. And I'm going to do some side work just so you know what I did. I'm going to take half of the middle term, the coefficient of the middle term. So there's half of 5 over 2, which is 5 over 4, and then I'm going to square it. So that is 25 over 16. So that's the piece that goes in this spot, 25 over 16, and you have to make sure you put it on the right side as well. So is that going to require us to deal with fractions? Yes, but is that part of life? Yes, so we're okay. Now to factor this into this perfect square trinomial into this binomial square, here's a little hint. The number that always goes right here is half of this middle term. So this half of -8 was -4. -4 is what I squared to get 16. So this number is always going to be the number that you squared right here. And so if you just don't feel like thinking about it, you can just take that, what you squared, and that'll be what's in the parentheses. So this is x plus, I mean, it's really just the square root of 25 over 16, which is 5 over 4. All right, and so we're going to have to add fractions over here, so I'm going to just bump up this 3/2. I'm going to just write it over here because I'm so out of space. I'm going to just, bump this over here. And so 2 has to scale up to 16 by a times 8. And so 3 is going to be times 8 also, and so this is going to be 24. All right, so that is a 49 over 16. Okay, so let's square root both sides. And don't forget the plus or minus. Square root both sides. So this is x plus 5 over 4 equals the square root of 49 is 7, and the square root of 16 is 4. So this is plus or minus 7 over 4. And then we're going to split our answers. So one answer will be the 7/4, and one answer will be the -7/4. And then we're just going to subtract 5/4 from that. So this is plus or minus 7/4 minus 5/4, and then we'll just put that with the split. So minus 5/4 minus 5/4, and so x here is equal to that 1/2. All right, and then x here is equal to -12 over 4, which is that -3. All right, so as anticipated, since this was the same problem as the one that factored up at the first method and the quadratic formula, we got some consistency here. We got x equals to 1/2 and -3 again with the third method. Okay, so let's see what we got over here. The last method here is the square root theorem, and this can only be used. I mean, we use the square root theorem with completing the square, but the perfect use for the square root theorem is when you don't have an x term. So isolate and take the square root. All right, quadratics, and these are of the form ax squared plus b equals c. There's no middle term, or I should say there's no x term. So you just have a square, and then you have something you can put together as a constant. And so this one would be 3x squared. You would minus 5, that's 21, divide out, and you get x squared equals 7. So square root theorem is when you've got something that you, x squared that can equal a constant. So we're going to take the square root of both sides. So that'll negate, and then this will be plus or minus root 7. Plus or minus root 7. All right, and so this is basically just asking, where does the left side of the equation intersect with the right? So you could, if you were to graph it with using the intersection method, you could either graph this, this parabola x squared minus 7 equals to 0, or you could graph the two parabolas. You could graph this parabola that's been shifted up 5 with a bit of a vertical stretch. Where does that equal 26? So either way, we'll just do the intersection method because that's where these notes are taking us. And if you went on your TI, you'd have to change your window. You would get this parabola, and then you would get this y equals to 26. This is y equal to 26. And this is your y1, that's your parabola, that's y2. And what you're finding are these 2 points here. So this would be root 7, 26, and this point here would be negative root 7, 26. And so you would need a window, maybe negative 10 by 10, and then you'd need to make sure you could just get up past that 26, so maybe 30. If you were to just graph it, from here, you would get x squared minus 7 equals 0, and you would be at a parabola like that is at 0, negative 7, and so you would find these 2 points, which would be root 7, 0, and this point here would be negative root 7, 0. So you could graph it from the beginning. You could graph it from the beginning and look at those intersection pieces. The graphs will look different, but the answers will be the same. This you're looking for where does it intersect 0. This you're looking for where does it intersect 26. Both x answers would be this plus or minus root 7. Okay, for all of these methods, be able to give exact and approximates. Your calculator only gives approximate answers. These are your decimals. Exact answers are your simplified radicals, the radicals, or reduced fractions. And approximate answers are your rounded decimal. All right, exact does not mean write every number that appears after the decimal on your calculator screen. Okay, so, just for example, pi is exact because it hasn't been rounded. And 3.14 is approximate because it has been rounded. But some people, think, oh, well, if I go further, 3.14, 15, well, I don't even know what it is, but 529, I think. People think, oh, that's approximate because or that's exact because I went out so much, but that's not true. This is still approximate. Okay, as long as you round, you're an approximate. Okay. So last thing here is the discriminant. You can determine the types, the kind of solutions that you're going to have just by looking at the discriminant. So the quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. And the key part of this formula is this square root of b squared minus 4ac, and really it's what is under it. Okay, so we saw this earlier in the notes when we got a perfect square under there, when we got 49, it told us something. It told us that it would factor. So the discriminant is going to be able to tell you lots of things. It's under the root, so we need it to be positive. It's okay if it's 0, and something special happens if it's a perfect square. It means it would have factored. So this b squared minus 4ac gives us a lot of information. And it's called the discriminant because it discriminates, which is not a nice word, but it's okay in math. it discriminates between the roots. All right, and so the discriminant is just what's underneath, b squared minus 4ac. All right, so if the discriminant is positive, that means positive, then you're going to get you're going to be able to get two real solutions. And just a side note, if it's a perfect square, then the quadratic is factorable. That's just a side note, just as a fun fact about the discriminant. If b squared minus 4ac is equal to 0, then you're going to lose that plus or minus. So you only get one real solution. You're losing that plus or minus. So you only get one real solution. Okay, so that would be just a parabola that just touched down on the x-axis and shot back up. It didn't actually cross it twice. It would just be one that it was tangent. And so this is one real solution because you lose that plus or minus. And then if b squared minus 4ac is less than 0, which means negative, this is 0 real solutions. You would actually get imaginary solutions here, 2 imaginary solutions, which we'll get to later. I'm just going to write that here. We'll get 2 imaginary. We'll get to that later. All right, so without solving, we're not going to solve. We're just going to discriminate between the roots. We're going to discriminate the type of roots. We're going to determine the number of real solutions by analyzing the discriminant. So we'll just go to b squared minus 4ac, not the root part, just the b squared minus 4ac. And so here we would get b squared, which is 16 minus 4 times 2 times 1. This is 16 minus 8. This is 8. Therefore, we would get 2 real solutions. 2 real solutions. Here, b squared minus 4ac. 1 minus 4 times 2 times 1. 1 minus 8 again, negative 7. Therefore, 0 real solutions. And finally, you do want to get everything set to 0. Okay, and b squared minus 4ac. I got negative 2 squared, which is 4, minus 4 times 1 times 1. 4 minus 4 is 0. That means you would get 1 real solution. You would lose that plus or minus because you'd have 0 under the root. So it would be basically be plus or minus 0. And just so you have a visual on this, this could be some situation where it just touches down like that. And that's just your one solution. All right, I'm not saying that this is this parabola here. This is just an example so you can understand what that means. All right, so that's the first 2 pages of 3.3. And if you took the test, hope you did well. And if you're taking the test later on this week, happy studying. All right, bye guys.